Good afternoon, everyone. This is topic 3. In this session, we will discuss about atomic structure and the periodic table. So, topic 3, the subtopic is about atomic structure and periodic table. First thing, the basic structure of the atom, and these are the learning objectives. So, after completing this session, like this explanation, you should be able to answer these objectives. So first start with the basic structure. What is the structure of atom? So an atom consists of a nucleus, and inside the nucleus we have subatomic particle which we call neutrons and protons. And around the nucleus there are particles which are revolving, and what we call them as electrons. So this is a basic structure of an atom, and the number of the proton, neutron and electron vary with different types of atoms. So we may have different types of atoms, but the basic structure that an atom consists of a nucleus. Inside the nucleus we have neutrons and protons, and around the nucleus electrons are moving. This is a basic structure of an atom, or picture of an atom. Then the definitions which you should learn related to the topic. First thing is about element. What is the meaning of element? Element means when identical atoms or identical molecules join together, what they will form? They will form an element. So when identical or similar atoms or similar molecules join together, and we already discussed about atoms and molecules in the first chapter. That example, we have this black shade is representing the atoms. So we have these atoms, and identical atoms are there. The term identical means same. So if we have same atoms together, what we call that substance? We call that substance as an element. Or if we have identical molecules, identical atoms join together to form a molecule, and if we have identical molecule, so what we call that substance? We also call that substance as an element. So both are the examples of element. When identical atoms join together, we call element. When identical molecules in which atoms are also identical, that will also make an element. And the simplest building block of a physical world. So there are about 92 naturally occurring elements. In nature, 92 elements are existing, and some of the elements are man-made, artificial. Like they are not present, we just create them by different techniques. Is it clear, the concept of element? So example, if I say sodium, so sodium is an element. Oxygen, oxygen is an element. And in sodium what happened? There are identical atoms, and in oxygen what we have? Identical atoms as well as joined together to form a molecule. So identical atoms join together to form a molecule, and because all are identical, same atoms, so what it gives? It is also an element. Is it clear, the concept of element? So a basic substance in which all the atoms are identical, all the atoms are same, we call that as element. About the atom we already discussed. the defining structure of an atom, which typically include a nucleus of neutron and proton, and electrons are orbiting or moving around, we call that as atom. And when two or more atoms join together, then what it will result in a formation of a molecule. And when two or different types of atoms chemically join together, what they will form? They will form a compound. So example, if you have a substance in which you have identical atoms, so what we call this substance, element or compound? Compound means two or more different types of atoms joined together. So what we call this, when identical atoms are there, so we call this substance as an element. Same thing, if we have group of identical atoms, like similar atoms joined together, identical atoms joined together, so this is because atoms are identical, so these are the molecules of element. This is element, that's right. Or we can also say this element, we have molecules of element. But if we have different types of atoms chemically joined together, so different types of atoms they chemically join together, so what we call this substance, when different types of atoms join together, we call that substance as compound. And when we have different types of compounds together, what we call that? We call that as a mixture. We can have different types of elements, different types of compounds joined together, mixed together. We call them as a mixture. So example, this is one type of compound. And then another type of compound. So what we call this as a mixture. So when we have different types of compounds together, or even different types of elements together, we also call that as a mixture. Like if I give another example of a mixture, say one type, this is one type, and the other is not chemically combined. Chemically, if they are not combined, they are separated from each other. So what we call this substance, element, mixture, or a compound? Is it an element? The substance is element, mixture, or compound? Yeah, what we call this substance, element, mixture, or compound? To be a compound, there's a chemical combination. Chemical combination means two or more atoms should join together. If it's a compound, then they should be joined together. But in this one, two different elements are there which are mixed together. There is no chemical combination. That's why this is not called a compound. This one is known as a mixture. Is it clear? So this is a mixture, a compound. The difference between them here, they are chemically joined together. Like example, if I say hydrogen mixed with chlorine, so it will form hydrogen chloride. But in this case, hydrogen is separate and chlorine is separate. They will have different properties, because when the two or more atoms join chemically, the properties will change as well. So the properties completely changes. The mixture, the property does not change. Well, but in a compound, it will have totally different properties as compared to the elements from which it is formed. Is it clear, the concept of element, mixture and compound? How you can identify if they're overlapping? Like example, one molecule is chemically combined with another, means they are joined together. It means it's a compound. But if they are not chemically combined together, then they are separated from each other. There will be a gap between them. So if they are chemically combined, this is chemical combination. And this is only a physical combination. They are not chemically combined together. Is it clear to everyone? Yes, Abdullah Sarfraz.
Sir, but in both process, the particles are combined. How would we know?
Particles are mixed together, but in one, they are chemically combined. So when they are chemically combined, they will stick together, remain together. But when they are not chemically combined, what happens? The particles can move away from each other. And how you can identify if there is a gap between them, it means they are not chemically combined. If there is no gap between them, it means they are chemically combined.
So in compound, they are not chemically combined.
In compound, they are chemically combined. You can see here that two substances are chemically combined here. They are overlapping. So this is a chemical combination. In mixture, they are
So
not chemically combined.
there is no particles which are away from each other. All of
Where?
them are joined
Which one?
in mixture.
This. How the particles
Above
are
one.
joined? The above one is a mixture of compound. This is compound one. Like you can see, this is compound. This is compound. This is compound. So this is one type of compound and this one is another type of compound. So when two different types of compounds are mixed together, what we call them, we also call them as a mixture. So this is a mixture of element and this is a mixture of compound, but both are the mixture. So mixture can have compounds, mixture can have elements. Yes, Abdullah, is it clear?
Yes, sir.
Another example. Now, what is this substance? Element, mixture, or compound? What is this substance? The color, I use the same color to show that they are identical or same. Maybe the size does not look similar, but I try to make the size similar as well. So this is, right now, this is element. Okay. Now, if I add another type, but they're not chemically mixed. How you identify they're not chemically mixed? Because they're not overlapping with each other. Now, what is this? So when two different types mix together, but this is a mixture of element, because two different types of elements are joined together. That's why it's a mixture of element. Then if I further change, what is this substance now? What we call this substance? You can use a chat or a screen annotation, or you can also use a mic to state the answer. So it is a compound, because two different types of atoms chemically join together, so it is a compound. If I further change, now what is this substance? So now it turned out to be a mixture. Why? Because two different types of compounds. So this is like compound type A. So two different types of compounds are together. That's why what we call that it's a mixture of compounds. So you can have a mixture of elements, or you can have a mixture of compound, or in short, you can say it is a mixture. So element means when identical atoms or identical molecules are together, we call that as an element. When we have a basic structure in which we have neutron, proton and electrons are revolving, we call that as atom. When group of atoms are there, it's not only two, it can be more than two, but if they're joined together, we call molecule. And molecule may have identical atom. If molecule is having all the atoms identical, that is element. But if molecule is having different types of atom, then it will be a compound. And compound means when two or more different types of atoms or element chemically join, we call compound. And when two or more substances not chemically bonded, we call that as a mixture. As you can see, the first one is atom, the structure of atom, and these are atoms of element. The second one is a molecule, and these are also molecule of element. Why? Because these are identical atoms to form a molecule. When different types of atoms chemically combine, we call for a compound. And when different types of substances mix together, not chemically mixed, just mixed together, we call that as a mixture. So this is the activity. I want everyone to use screen annotation and type the answer for A. What is A? You can use screen annotation, or you can use the chat to state the answer. What is A? Element, mixture or a compound? For element you can write E. For mixture you can write M, and for compound you can write C. So the first one, that is a compound. You can write it on this. So that's right. What about B? B, different types of atoms or molecules, so it means it is a mixture. That's correct. What about C? And C, different types of substances are there, so that's a mixture. That's correct. What about D? D is having identical So it's a compound. That's correct. What about E? E is actually identical molecules are there, so it is an element. This is not the compound. This why it's an element, because identical molecules are there, so it is an element. What about F? Identical atoms, so it is also an element. Here different types, so it is not a compound, it is a mixture. What about H? Identical atoms, so that's element. And the last one is a compound. Is it clear to everyone? Yeah, that's right, a compound. So compound, the first one is a compound, second one is a mixture, third one is a mixture, fourth one is a compound, fifth one element, sixth is element, seventh is a compound mixture, eighth is element, and ninth one is a compound. In which row are substances correctly classified? So brass is an alloy or a mixture. Alloys are mixture. So what could be the right answer? Compound in which there is a chemical combination. Brass is the columns. Which column is correct? You have element, you have compound, and you have mixture. So which one? Element. Element means in which all the atoms are identical. So how you can identify the element? For elements, you can check the periodic table. I will show you the periodic table. Just a minute. What you see in the periodic table are all elements. Okay. So can you find sulfur here? So you can see sulfur is in group 6. That is the position of sulfur. So this is the periodic table is showing the elements only. So these are all elements. So sulfur is an element. So first column, the element should be sulfur. The second, compound. Water is a compound. How water is a compound? Because water is a mixture of two hydrogen and one oxygen, which are chemically combined together, H2O. That's why we write water as H2O. So water is a compound. And what about mixture? Brass is an alloy, or which is a mixture. So the correct answer for this one is C. Is it clear, this question? Then another topic, which is about the relative mass and relative charge of electron, proton, and neutron. So you have to memorize this table. How you would know that things are mixed in the substance? As you go through as we complete the syllabus, you will be able to identify or recognize different types of material or substances. So brass, about the brass, you will learn in chapter 11, uh, which is about the elements. So we have subatomic particles as proton, neutron, and electrons. The actual mass, when I write the actual mass of proton, neutron, and electron, the actual mass of proton is equals to 1.6 into 10 raised to power minus 27 kilogram. This is the mass of proton. Mass of neutron is 1.6 into 10 raised to power minus 27 kilogram. And mass of electron is 9.11 into 10 to the power minus 31 kilogram. These are their actual masses. But when we take a relative mass, what is the meaning of relative mass? When we compare their masses, how to take a relative mass? When we divide by a common number, like here it is 1.6, the mass of proton, which is 1.6 into 10 to the power minus 27. Mass of neutron is also 1.6 into 10 to the power minus 27. And mass of electron is 9.11 into 10 to the power minus 31. But when I take a relative mass, means I'm taking a ratio. So when I take a ratio, I divide all of them by the common number here, which is 1.6 into 10 to the power minus 27. So if I divide this by 1.6 into 10 to the power minus 27, 1.6 into 10 to the power minus 27, and 1.6 into 10 to the power minus 27. So when I divide these by 1.6 into 10 to the power minus 27, what will be the answer? The comparison, it will be 1 for proton, it will be 1 for neutron, and it will be 1 divided by 1840 for electron. So basically relative mass is a comparison. How you relate the mass, like example, I will give an example. Say student A is having a mass of 60 kilogram, okay, and student B is having a mass of 120 kilogram. That these are the actual masses. So example, student A is having the actual mass of 60 kilogram and student B is having an actual mass of 120. But if I say what is the relative mass, means when I compare their masses, so if I take a simplest ratio, so to take a simplest ratio, I divide both of them by 60. So this will be 1 and this will be 2. So it means that student B mass is twice as compared to student A. So same thing, when we take a relative mass of proton, neutron and electron, so relative mass of proton is 1, relative mass of neutron is 1, and relative mass of electron is 1 divided by 1837 is accurate, but 1840 you can write, that is the relative mass. Is it clear? The concept of the relative mass, the comparison mass or relative mass. So when we take a simplest ratio of the actual masses of proton, neutron and electron, the simplest ratio for proton is 1, for neutron is 1, and for electron is 1 divided by 1840. So you have to learn their relative masses. That proton, relative mass of proton is 1, relative mass of neutron is 1, and relative mass of electron is 1 divided by 1836, or you can also say 1 divided by 1840. So basically what you have to do, you have to memorize these. When proton and neutron is coming out 1 and 1, so it means proton and neutron have the same mass, and electron is lighter because 1 divided by 1836 compared to proton and electrons, proton and neutron. So basically you have to learn or memorize. You don't have to learn the theory about this. The thing which you have to learn is the values for relative mass. Even the actual mass, you don't have to learn or memorize the actual mass. For explanation, I use these numbers, the actual mass. So mass of proton is 1.6 into 10 to the power minus 27. Mass of neutron is 1.6 into 10 to the power minus 27. And mass of electron is 9.11 into 10 to the power minus 31. But when we take a simplest ratio, when we divide all the values by 1.6 into 10 to the power minus 27, the proton, because if I divide the same number, I will get 1. So for proton, it will come out 1. For neutron, it will come out 1. And for electron, it will be 1 divided by 1840 or 1836 or 37. You can write any of them. And same thing, so simply the term relative means comparison. Like if I give another example, you have student A, B, and C. Student A is having a mass of 80 kilogram. Student B is having a mass of 80 kilogram. And student C is having a mass of 40 kilogram. So when I take a simplest ratio or they take their relative mass comparison, so what I can do to take the relative mass, I can take a simplest ratio. If I divide all of them by 40, because 40 is a common number. So if I divide all of them by 40, this will come out as 2, this will come out as 2, and this will be 1. So the relative mass is 2, 2, and 1, whereas actual mass is 80, 80, and 40. Is it clear? This concept of relative mass or the comparative mass? Yes, Abdullah Sarfraz.
So we will take the smallest value.
You can take the smallest value or you can take the largest value and divide them. What numbers you get, you will get the, like I can also solve this as, if I want to take a relative mass, I have this 80 kilogram, I have this as 80 kilogram, and I have this as 40 kilogram. So if I take the simplest ratio, I will divide by smallest value, but I can take a largest value. If I divide all of them by 80, then this will be 1, this will be 1, and this will be 0.5. So I can say their relative mass is 1, 1, and 0.5, or I can say their relative mass is 2, 2, and 1. So it can be done both ways. Both ways are correct. So same thing, what we did, we have the actual masses of proton, neutron, and electron. So we divide them by 1.6 into 10 to the power minus 27. So we'll get, for proton, we'll get 1. For neutron, we'll get 1. And for electron, it will be in decimals, but instead of writing in decimal, we just write in fraction, which is 1 divided by 1840 or 1836 or 37. You can also write. Is it clear, Abdullah Sarfraz?
So what this topic is trying to explain, like the
This
mass of a
topic is
substance.
trying to explain the comparison of the mass of proton, neutron, and electron. So when we compare the mass of proton, neutron, and electron, this shows that proton and neutron are heavier and electron is the lighter one. So it's a comparison of the mass. So if I say which particle is heavy, so proton and neutrons are the heavy particles in an atom. Which particle is the lightest? So electron is the lightest particle in the atom. And when we compare, is it clear, Abdullah?
Yes, so sir, proton is the heaviest.
Proton and neutron both are having the same mass, so both are heavy.
Okay, sir.
And electron is lighter compared to proton and neutron. And how many times it is lighter? It is 1 divided by 1836 times or 1840 times lighter compared to that of proton or neutron. And when we compare the charge, the proton is positive charge, electron is negatively charged, and neutron does not have any charge. So in exam, you will find how they give this question. They normally give you the table and they ask complete the table. That is the main thing they ask. for relative mass and relative charge. So how we complete this table? For proton, what we will write? So we'll write 1. For neutron, we'll write 1. And for electron, you can write 1 over 1840, or you can write 1 over 1836 or 37. Both are acceptable. And the charges, proton is plus positive charge, neutron does not have charge, and electron is negatively charged. So that's why the whole atom is a neutral. Why the whole atom is neutral? Because it contains equal number of protons and electrons. Then the concept of the ions, the charged particle that are formed when atom lose or gain electron, we call that as ion. Atoms can lose electron, atoms can gain electron. So what it form? It will form an ion. So if we have equal number of proton and electron, we call that as atom. But if we have more protons than electron, we call that as a positive ion, or it's also known as a cation. If we have more electron, less protons, then we call that as Ni. So you can see in the first figure, how many protons are there? Neutrons are not shown because they are neutral. How many protons are there in the figure? How many protons are shown? So there are 4 protons. So total there are 4 protons in this one. And how many electrons are there? So there are 3 electrons. So what will be the charge on this? How you can identify the charge? So proton is positive, so there are 4 positive and there are 3 negative. So what is the overall charge on this? Plus 4 and minus 3. What is the resultant charge? So it will be plus 1. Resultant charge will be positive or plus 1. And when you check the other one, it contains 4 protons and it contains 5 electrons. So when you work out the charge, 4 protons means plus 4, 5 electron means minus 5. So when you find the total charge will come out 1 minus or minus 1. So the negative charges are known as anions, whereas positive charges are known as cations. And there is a reason why this specific cation and anion is used that we will discuss in electrolysis. But you should be able to identify the charge, and how you will identify a charge, you can check the number of proton and electron. If protons are more, then it will be positive, and electrons are more, it will be negative. Is it clear, the concept of the ions to everyone? And if I make, like example, if I make 5 protons, so if we have 5 protons and 3 electrons, so the charge will be plus 2. So the charge can change depending on the number of protons and how the atoms form the charge. It will either lose or gain. If it lose electron, it will form a positive. If it gain electron, it will form a negative. Less than a minute left, so I'll share another link and continue this discussion.